All right, let's have a look at the concept of maxima and minima. And I've chosen a graph here. I've got y equals x squared minus x minus 6. And the reason I've chosen that one is because it's nice and simple to draw. So let's just go ahead and we're going to factorize it first of all. So I can just plot it straight away. I can just write a sketch of it. So here we go. We've got an x and an x. Signs are different, plus and minus. The biggest one is going to be negative, and I'm going to have values of 2 and 3. 2 3 is a 6. 2 and 2 times 3, or sorry, 2 plus 3 or 2 minus 3 will yield a 1 of some sort if I subtract them. So we've got a negative. This is going to be the biggest one is going to be negative. So here's negative 3, positive 2. So if I draw this thing, we can say either. I'm contending with dogs barking in the background. I don't know if you can hear that. X is negative 2, or x is equal to 3. So if I was to plot that, here we go. I'll try and plot it as best I can. We've got a negative 2 here. There's my negative 2. We've got a positive 3. That's my positive 3 value. And it's going to come down something like this. It's going to turn around. It's going to come back up like this and head up through there. And the value at this point here is going to be 2 times negative 3, which is going to be a 6. But that's not actually going to be the turning point. The turning point can be slightly over this side a bit, yeah? The actual turning point's more like there, so it actually comes down more like there, yeah? So the turning point's a bit lower, and we can tell where the turning point is because we can actually use calculus for that too. We can use the expression minus b over 2a, which is actually a calculus expression, and that's the turning point. It's derived by calculus. So we've got minus b, well, b is that negative 1. So this is going to equal negative 1 all over 2 times a. Well, the a value here is going to be a 1. So it's 2 times 1. So it's going to negative 1 is 1 over 2 times 1 is 2. And so we know the minimum point, the value of the x value, the minimum point is going to be a half. And if I was to substitute a half back into here or put a half into here, it's easy to put it into here. Let's have a look. Half plus 2 is going to be, half plus 2 is going to be 2.5. And half minus 3 is going to be negative 2.5. And 2.5 times negative 2.5 is going to be negative 6.25. So the lowest value there, it's actually going to, if I zoom in on that bit there, it's going to come down like this, here. Here is where it crosses the x-axis, it's going to be 6. But it drops down just a little bit lower. That's the minimum point, and that's going to be negative 6.25. So we're now looking at the minimum possible value this could be. We can see it's a minimum value, but let's prove it with calculus. So let's have a look. Let's go ahead and we'll restate the question. So it's going to be y is x squared minus x minus, what am I doing? Minus 6. You've got to be able to see what I'm writing here. So dy dx, we're going to differentiate it. That's going to be 2x minus 1. Differentiate again. We're going to have d squared y over dx squared. And by doing the second time, we get a value. Now, I'm not particularly concerned with how big or small this value is, only that it is either less than 0 or greater than 0. So if it was 3, 2, or 200, or 2 billion, doesn't matter. What matters is that this, in fact, is a minimum value. And it's a minimum value because value is going to be greater than 0. Now, if the value was less than 0, it would be a maximum. And if the value was equal to 0, it would be called what we call a point of inflection. No, it's neither of those things. Instead, it is just a minimum value, and it's minimum because the value here is in fact greater than 0. So that tells us that whatever the turning point is here, it is in fact a minimum. So this is now recognized as a minimum point. The turning point is in fact a minimum. And that's how we know.